Let's look at some properties of continuous functions. And why would we care about properties of continuous functions? Because if you're trying to determine the continuity of a function, whether it is continuous at a certain point or interval or not, and it is made up of some other functions that we already know about, whether they are continuous, then we can use these properties to find out if the resulting function is continuous or not. So we don't have to necessarily do the 3 checks to figure out if it is continuous. Just like we did for limits, right? If we know the limits of 2 functions and we are adding them to make a third function, we were able to use the properties of limits to figure out the limit for the sum, right? Similarly, there are some properties of continuous functions which we can use to determine the continuity of function made up from other functions, right? So for example, suppose we have f and g, 2 functions. F and g are 2 functions, 2 continuous functions at a. So these are continuous at x equals a. These are functions of x. So both of these are continuous at a, and suppose c is a constant. Then these properties we can use. So sum or difference. That means f plus g and f minus g. These are also continuous. Okay. And scalar multiple. So c times f of x, right? That is also continuous, or the product of the functions. So f of x times, these are all f of x and g of x. This is also continuous at x equals a. Quotient f over g is continuous if g of x is not equal to 0. Okay, and we're talking about at x equals a. So if we know about f and g being continuous, then we can make new functions by combining them in different ways, and those are also continuous according to these properties, right? And we can also look at composite functions like we looked at earlier. So if g is continuous, it's a composite also. Let's look at. So g is continuous at a, if this is known, and f is continuous at g of a. And we'll see why we have to look at that value, because we are looking at the composite function. So f of g of x, right? Which means f of g of x. Right? What does that mean? That first x goes into, what does x go into? First we have to compute this, right? So x goes into g and then it gets g of x out, right? G of x is going into f, right? F of g of x, right? So that is why if g is continuous at x equals a, if x is a, right, then we will get g of a here, correct? And then g of a is going into f, and then you will get f of g of a, correct? That is why this is saying f has to be continuous at this one. If g is continuous at a, f is continuous at g of a, then we will get f of g of a, right? So if these conditions are true, that g is continuous at x equals a and f is continuous at g of a, then f of g of x is also continuous. So these are the results. These are the properties of continuous functions, using which you can figure out if a function is continuous. If it is made of some other functions and you knew that those functions were continuous at that point, then we can say that the new function is also continuous if it follows one of these properties. Let's look at an example. So let's say you have g of x is 2x squared plus 1. Okay, and let's say f of x is sine of x. and you know that this is a polynomial, right? Is it continuous? What kind of function is that? It's a quadratic. It's a parabola, right? If you graph it, it's like this. It's continuous, right? There is no break. And this one, it's like that, right? Keeps on going forever. Both of these are continuous everywhere. Right? So any point we take, let's say we will take, say, x equals 3, right? Then g is continuous at 3, correct? And what is g of 3? 19. F of x is continuous at 19 because it's continuous everywhere, right? And no matter what you take, 0, so 19 is somewhere here. It's continuous because it's just repeating that same pattern. So f of x is continuous at 19. Therefore, by the composite function property, f of g of x is continuous at 3. This is where we're looking at x equals 3, right? They're continuous everywhere anyway, because they're already continuous everywhere. But if you have to solve a problem, you are looking at one particular point. So first we have 3. 3 is going into G, right? This is G and this is F. So 3 went into this and we got 19. And then this 19 went into this function because f of g of x, right? This is x, this is g of x, and then this f is of g of x. So whatever this is, that is becoming the input here. And we are seeing if this function, if this is 19, then at 19, is it continuous or not? Right?